Page 394, Pivot Tables and Pivot Charts. A type of an Excel table that allows easy switching or pivoting of rows and columns are often called fields, is called a pivot table. And below we have an abbreviated example of a chemical inventory database table. This is a list of chemicals kept in storage. Now every institution that stores chemicals must keep both a digital and paper copy listing all the chemicals that are stored and their locations and their quantities. This has to be made available to the local firefighters for obvious reasons. Now a chemical inventory database table must have no blank rows or columns, and each record, each horizontal row must have a unique identifier. This is an ID number. Let's look at this table just briefly. We have the formal name here called the chemical name for the chemicals listed. They're not necessarily unique chemicals. I see hydrogen chloride occurs more than once, and we'll explain why later. The common name for each chemical, the chemical formula. Then we have these hazard codes. Let's scroll down and quickly read what these are. A stands for acid, B is for base, C is for corrosive, CG for carcinogen, D for dangerously reactive, F for flammable, N for non-hazardous, M for mutagen, O for oxidizer, P for poison, and T for teratogen. Then we have the grade. The grade is akin to a purity classification. Chemicals are sold according to grade specific to purposes. ACS stands for American Chemical Society. Technical grade is a lower grade suitable for general work. Certified, primary standard, UV spectroscopy grade, HPLC grade, food grade, and so on. Then we have the assay, which is usually percent by weight. Suppliers, who sold us the chemicals. The date the chemical was received, and the material safety data sheet expiry date must be tracked. The location in which the chemicals are stored. In this particular case we have 6 different locations, room 401 through 406, plus a dynamite shack, DS. The quantity in kilograms of each chemical stored, and the approximate value, the monetary value. Let's take a look at an Excel spreadsheet and show you how we can create pivot tables and charts from this existing table. This Excel file is called SPC Charts. The worksheet is Pivot Table. Let's begin by selecting the entire table. An easy way to do that is select any cell on the table and choose Control-Shift-8, which is Control Asterisk, to select the entire table. Let's give it a name. In the name box we can type in chem_inv for chem inventory. Remember, a name can't have any spaces. And press enter. To create a pivot table and a pivot chart from the data, just make sure the table is selected and choose Insert. Under the Charts group, Pivot Chart, choose Pivot Chart and Pivot Table. Now in the Create Pivot Table dialog box, we see the range that's going to be selected, A1 to M19, just make sure that's correct. Choose where you want the pivot table to be placed. We're going to choose a new worksheet. You'll need the space. That's about it. Say OK. So a new worksheet has been created, and you'll see a blank placeholder for a chart and a blank placeholder for a table. A formatting pane also opens on the right hand side of the screen. It's labeled Pivot Table Fields. In the Pivot Table Fields pane, we see a list of all of the columns or fields of information that was in our table. None of them are currently selected. There are also 4 quadrants called drop zones. And the idea is that we can select and drag and drop any of these fields into the 4 quadrants to create a table and chart specific to what we want to look at. So for example, if we select common name and drag it into the axis categories, we see a list of all the common names of our 18 chemicals. Let's also add location. We'll drag that into the axis categories as well. Now the locations of those 18 chemicals are also present. Now in order to graph something we need values, numeric values. So let's include the quantity, and this should be dropped into the sum of values quadrant. And notice now we have values or quantities in kilograms. We can also add value to the same sum of values. Now we actually have 2 different variables plotted. Notice that the information in our table is expanding. We have the quantity of each chemical and the value, the cost, and our chart is also expanding, although it looks a little cramped. Let's see if we can work on that a bit. Let's try unselecting common name and then re-add them. Okay, now we have it worked out. We can see both location and the common names. Notice that in the bottom of the chart, a filter is created for each field. So I could select various locations. I could select room 404 only, and the chart is recreated. How about common names? Let's unselect all and just choose a few. Say OK. It's a very simple way to customize a chart and a table. Let's say we wanted to format our values as currency. Just select any value, go to Pivot Table Analyze, go to Field Settings, and then choose Number Format. Let's choose Currency. I'm going to remove all decimal places to simplify it and say OK and OK, and now our values are shown as currency values. Let's try adding the hazard class to our table and chart. We'll select that. Notice it drops into the axis category by default. You could drag it there. So we see the chemical hazard codes. Again, it looks a bit cramped here, so let's unselect common name and reselect it, and now it's fitted it properly. Our pivot table has chemical names, hazard codes, locations, quantity of each chemical, and the value of each. Quite handy. Let's go back to the situation where we have on the common name and location both in the axis categories quadrant. Nothing to plot here, we have no values. But try this, try dragging the supplier name into the sum of values quadrant. It does plot some values, but they're not very meaningful. This is just a count of the suppliers. But also try dragging supplier into columns. This is interesting. Let's take a look at the pivot table. Now, before we try and read it, let's add some colored bands to this. Click anywhere in the table and go to Design and select Banded Columns. Alright, what's this telling us? We have 401, 402, 403, 404. Here are the 3 chemicals in 401. Here are the suppliers. So there's 1 chemical from Sergeant Welch in 401 and 2 from VWR. And here's the breakdown. Acetic acid is in 401. It's supplied by VWR. And then we have baking soda, also from VWR in 401. And here's hydrochloric acid, 1 chemical from Sergeant Welch in 401. So I think you can see that pivot charts and pivot tables are easily customizable, and for this reason potentially quite useful. Now it will likely happen that over time you may add more records to your table, and you'll likely want to include the new data in the table. So if you want to change the data range, just click on any cell in the pivot table, then click on the Analyze tab, then click on Change Data Source, Change Data Source. Now you can reselect the new data range to include in your table and say OK. If you don't see your data range update, go back to the Pivot Table Analyze menu and click on Refresh. There's one more piece we can add to a pivot table and a pivot chart, and they're called slicers, which are customizable filters. So I've gone back and removed all the fields, and we'll start afresh. Let's just choose common name and location to start. We have a table for that, nothing to plot. Let's choose hazard and also add hazard to the sum of values quadrant. Let's also drag it into the legend series quadrant. Alright, so we have a pivot table and a pivot chart. Now, with any cell selected in the pivot table, on the Pivot Table Analyze menu, choose to insert a slicer. Here's a list of all of the current fields available. Let's just select those fields that we already have in the table. So choose the common name and the hazard and the location. Say OK. Now these are customizable filters, as you see. They can be resized, they can be removed. I can select a particular slicer and go to the Slicer tab and choose a number of columns I want to display. These can be modified. Now by default, all of the options or categories are selected in each slicer, but we can be more selective. Let's say I just wanted 406, hold down the Control key, I'll add 404. Hold down the Control key, I'll add 402. Let's select only certain hazards. And how about certain chemicals? Well, that would restrict it quite a bit, but you get the idea. Slicers are quite a handy way to filter the information in your table or in your chart. And that should be sufficient to give you an introduction to pivot tables and pivot charts. Page 402, Error Bars. Error bars are used to show the variation in replicate analysis when means are plotted. These are error bars on the Y values in a plot of absorbance versus concentration of nickel. Let's take a look at the Excel spreadsheet to see how these are added. Here's the data for standard solutions with concentrations from 1 to 15 milligrams per liter of nickel. Each standard was run 5 times, and we're going to get the mean and the standard deviation of each group of samples. Equals average of the 5 values. Enter, and we can autofill down by double-clicking on the autofill arrow. We also want the standard deviation for each set of samples equals stdev.s for a sample. Again, select the 5 samples that are being averaged and enter. We can autofill the standard deviation by double-clicking on the autofill arrow. Now we're going to plot a graph. Absorbance, that's mean absorbance versus concentration. Select the X values, then hold down the Control key and select the mean absorbance values. They're non-adjoining, so you hold down the Control key. On the Insert tab, choose a scatter plot, just points. I'll choose Chart Design, Quick Layout number 1. The X-axis title will be nickel in milligrams per liter, and the Y-axis title is absorbance. Our chart title will be absorbance versus concentration of nickel, and I'll put in brackets error bars, equals, I want to say plus or minus 1 sigma. Now the plus or minus character is one of the ASCII characters that you can use with an automatic key function. I'm using the laptop, so I'm holding down the Alt function and I'll press 241, and there it is, plus minus. On a regular full keyboard, just use the numeric keyboard on the right hand side and hold down the Alt key and press 241. Plus or minus 1 standard deviation. We don't need a legend since we only have one data series. Let's right click on one of the points and add a trend line. It's certainly curved. We'll add a polynomial, second order, display the equation of the chart, display the R-squared value. This is a reasonably good fit. We'd like to show the error bars on the Y values. They would represent the standard deviation of the samples. So with the chart selected, choose the Add Chart Elements tool, select error bars. Notice that error bars are added to the Y's as well as the X's. We're going to delete the X value error bars and then refine the Y value error bars. So to the right of error bars, choose the right arrow, click More Options. Under error bar options, click the list arrow and notice that X error bars are selected. Just click on that so the box closes. Now we can delete the X error bars. We're using the delete key. Now we have just Y error bars. But what are these values? Let's refine them. Let's make them equal to plus or minus 1 standard deviation. So go back to the Add Chart Elements button, back to the error bars right arrow, More Options. Here we have the error amount is set to a standard error. Let's customize it. Choose Custom and then specify value. So whatever this value is equals 1. Let's delete that and we'll add the actual standard deviation values. That's the positive values. Delete the negative ones and add our standard deviation for the negative ones. Say OK. There's our standard deviation plus or minus the Y value as error bars. Easily done in Excel. Let me show you one more example where error bars could be of use. We'll go back to our Excel file entitled Regression 2020 on the worksheet called UCX, that is standard uncertainty for a quadratic. Recall that we plotted this calibration curve for sodium on the flame photometer, concentration versus intensity. Here's the graph, clearly quadratic with a very nice R-squared fit of 4 nines. What I'd like to do is put our uncertainties, our X uncertainties on this graph. Now we calculated previously just the standard uncertainties for the standards, but I'd like to plot the expanded uncertainties at the 95% confidence level for the X values, the standard concentrations. Recall that that was equal to T times S. The T value is equal to T.INV 2T for two-tailed at the 95% confidence level and n minus 3 degrees of freedom for a quadratic. We had 6 data points. 6 minus 3 is 3. The value is 3.18. For the 95% confidence limits uncertainty, we multiply the T value of 3.18 times each of the standard uncertainties, and these then are the values I want to plot on my graph as expanded uncertainties, that is error bars for the X values. I select the graph, click the Add Chart Elements icon, select error bars. Notice we've got both Y and X error bars, which are apparently meaningless values. We want to eliminate the Y's and then specify the X. Choose the right arrow beside error bars. choose More Options. On the error bar options list, let's select the Y error bars so that they are selected. Delete them with the delete key. And now let's specify the X error bars. Again, click Add Chart Elements, Error Bars, right arrow, More Options. Want to select Custom, Specify Value. We're going to enter the expanded uncertainties as plus and minus error bars. We'll delete what's there and scroll over the expanded uncertainties as the positive errors, and likewise for the negative values, and say OK. And there they are. They're pretty small because our R squared is quite good, 9999. If we want to make these a little more visible, I'm going to select my series values, select the chart, choose the Format tab. This is really a useful tool here when you just can't select what you want. Choose Series 1. So these points are now selected. And now we have the Line and Fill option is selected. We want Markers, Marker Options. We could leave it as built-in, but let's make them much smaller so they will be less interfering with our error bars. And that looks pretty good. So there they are. X error bars representing plus or minus 3.18 standard deviations. That's the 95% confidence limits of the standards. And that's probably enough for error bars. And this also brings us to the end of our study of Excel in this course. Now there are many other applications of Excel in the notes that are not covered in this course and therefore are not presented by video lessons. For example, standard addition, known addition, more methods for comparing the means of different analysis, and more applications of matrix algebra. In your final semester, when students are working on their own projects, some of this additional material may be of use to you at that time. Excel is certainly one of the most powerful, if not the most powerful tool available for technologists, and the time you invest in it will likely be well rewarded. I hope these lectures were helpful. Thanks for watching.